Hey everyone, and welcome! Today we're putting on our detective hats and diving deep into a new case file. Our mission, should we choose to accept it, is to track down these mysterious figures that lurk in our data, the ones that can completely derail an entire analysis. Yup, we are talking about outliers. Let's get this investigation started. I mean, really think about that for a second. Imagine you've spent days, maybe weeks, gathering your data. You've cleaned it up, and you are ready to build something amazing. But hiding in there, just one single rogue number is waiting to sabotage everything. That, right there, is the power and the danger of an outlier. So here's our game plan for today, our official case file. First, we're going to identify our main suspect. What exactly is an outlier? Then we'll survey the crime scene and see why they cause so much trouble. After that, we'll crack open our detective's toolkit to learn how to find them. And finally, the big one. We'll deliver the verdict. Do we keep them or do we get rid of them? All right, first things first. Every good detective needs a clear description of their suspect. So, who is this character that seems to cause so much chaos in our data? At its heart, the definition is actually super simple. An outlier is just the odd one out. It's that single observation in your data set that just doesn't seem to belong. It's so different from everything else that it practically jumps off the page, sticking out like a sore thumb. To put it another way, and this is a fun analogy, think of that classic neighborhood kid who is so perfect at everything that they make all the other kids look kind of average by comparison. Well, an outlier does the exact same thing in a data set. It's an extreme value that completely skews how you see the rest of the group. And you see this kind of stuff in the real world all the time. So picture this. You've got a list of exam scores. Most students are landing somewhere between 40 and 90. But then you see a score of -20 or 450. Those are clearly outliers, and let's be honest, probably data entry errors. Or think about salaries at a company. Most people might be making around $30,000 to $40,000, but the CEO's $1 million salary, that's a totally valid data point, but it's an extreme outlier that sure doesn't represent a typical employee's pay. Okay, so we know what they look like, but what kind of damage can they actually do? Let's take a look around the crime scene and really understand why these outliers are such a massive deal for anyone working with data. All right, check out this data set. It's perfectly normal, right? Just four numbers, all hanging out together pretty closely. If you wanted to find the average, you could do it in your head. It's 13. Nice and simple. But what happens when our main suspect, the number 100, decides to crash the party? All of a sudden, our neat little group has been infiltrated. You can just feel that something is about to go very, very wrong with our average. And boom, there it is. The new average is 30.4. That one single outlier just dragged the mean all the way up from 13 to over 30. So let me ask you, is 30.4 a good representation of this group of numbers? Absolutely not. Almost all the numbers are in the teens. That outlier has given us a completely misleading picture of our data. And this kind of distortion gets really dangerous when we start talking about training machine learning models. Outliers can literally trick a model, pulling its logic in the wrong direction and leading to some awful predictions. Models that rely heavily on distance or averages, think linear regression or k-means clustering, they are especially easy to fool with these extreme values. Okay, so we've established that our suspect is dangerous. Now it's time to gear up. Let's open our toolkit and learn how to formally track these outliers down. The investigation is officially on. So in our detective's toolkit, we've got two main gadgets for hunting outliers. First up, we've got the Z-score method. Think of this as looking for a data point that's standing way, way far away from the main crowd. It works best when your data looks like a nice, symmetrical bell curve. Then we have the IQR method. This one's a bit more versatile. It finds the range where the middle 50% of your data lives, and anything that falls way outside that central box gets flagged. It's perfect for data that's a little skewed or not so perfectly shaped. So, we've used our tools, we've identified our suspects, we've got them cornered. But finding them, that's only half the battle. Now comes the most critical part of any investigation, the verdict. What do we actually do with them? But hold on. Before we do anything, we need to sear this one piece of advice into our brains. It's a golden rule. Do not remove outliers blindly. This isn't a simple case of finding the odd one out and just deleting it. Sometimes, removing an outlier can be an even bigger mistake than keeping it. So, if we can't just hit the delete key every time, what are our options? Well, a good data detective always considers all the possibilities before making that final call. We've basically got four main strategies in our playbook. First, we can remove it. This is usually the right call for obvious mistakes, like someone's age being listed as 300. Second, we can cap it. So instead of deleting it, we just dial down its extremity a bit, replacing it with the nearest normal value. This is great when you can't afford to lose a single data point. Third, we can transform our data. This involves using a math function, like a log, to kind of pull the outlier in closer to the rest of the group. And finally, and this one is so important, sometimes the best move is to keep it. If that outlier is a rare but very real event, like a case of credit card fraud, it might just be the most important clue in your entire dataset. And all of this brings us to the most important lesson of our entire investigation. It's the moral of the story, or as I like to call it, the outlier's golden rule. After everything we've talked about, let's just ask ourselves this one last time. Are these extreme values just mistakes? Are they simply noise that we need to clean up and get rid of? And the answer is a huge, resounding no. The biggest takeaway today is this: outliers are not always wrong. They are often trying to tell you something really important. They can be the signal, not just the noise. They could be pointing to a mistake in how you collected your data, a flaw in your thinking, or maybe even a groundbreaking discovery. So the next time you find an outlier, don't just delete it. Interrogate it. Ask it what story it's trying to tell you. Because